Okay, so today we're going to finish up the examples from the notes from Chapter 4, Section 4. So I'm going to start with number 5, because I did 1 through 4 yesterday. So again, notice there's only one squared term here, and it's the y squared. So because I don't have an x squared in here as well, this tells me it's going to be a parabola once I'm done. So I'm going to go ahead, and I always like my square term to be positive. So before I even begin here, I'm going to divide everything by -1. So I'm going to flip all my signs, make this positive 2y squared, negative x, positive 20y, positive 49 equals 0. Since it's a parabola, I need to move everything over to the right except for anything that has a y. So I'm going to leave the 2y squared and the 20y by itself on the left. And then I'm going to add the x and subtract the 49. Actually, let me just put it as x minus 49. Next, when I'm completing the square, so for this, I need to first make sure that the number in front of my y squared is a 1. So I'm going to divide by a 2. So I'm left with y squared plus 10y. Leave a blank space. And then write the x minus 49. Next, what I need to do is take the b term here, the 10, divide it by 2 and square it. So 5 squared is 25. So in here I'm going to put plus 5 squared. But what I'm going to add to the other side, I need to remember the 2 that I factored out, times it by 5 squared, which is 25. So what I'm adding over here is going to be a positive 50. I can now factor my perfect square trinomial, and I get 2 times y plus 5 squared equals, and I can also simplify this negative 49 plus 50, and I end up with x plus 1. I need to have the x squared all by, or the y squared all by itself. So I need to divide both sides by 2. So the final answer in standard form is going to be y plus 5 squared equals 1/2 x plus 1. I now have my parabola in standard form. I can pull out my vertex. This is K, this is H. So my vertex is located at -1, -5. I now need to calculate the value of P. Remember right here, this 1/2 is equal to 4P. So I'm going to do 4P equals 1/2. Whenever my 4P equals a fraction, I like to solve this as a proportion. So I could add a 1 here. And then I can multiply and do the cross products. It doesn't matter how you solve for P. If you'd rather divide by 4, that's fine as well. So I end up with 8P equals 1. Divide by 8, and my P value is 1/8. Again, remember the value of P is how far away is the vertex from the focus, and how far away is that vertex from the directrix. So in order to get the ordered pair for my focus, I'm going to take the vertex, and I'm going to be adding the p-value to the non-squared variable. So my non-squared variable was x, so I'm going to add 1/8 to the x of the vertex. Yes?
When you do completing this here, where did you get the x plus 1 from?
After I subtracted up here where I underlined in blue, I did -49 plus 50, which then turns into a positive 1.
Thank you.
Okay, so then now I'm going to go ahead and simplify this for my focus point. I can make the -1 8/8, and then I get -7/8, comma -5. This is my focus point. For my directrix, I use the opposite of P. and I'm going to take x equals -1 minus 1/8. So my directrix is located at -1 1/8. If WebAssign prefers it as an improper fraction, this would be -9/8. For graphing purposes, I would rather see it like this so you know exactly where to draw that line. I also need my axis of symmetry. That comes from the vertex. So for the axis of symmetry, it's going to be y equals -5. I also need an additional point. Since it's a y squared, let me go ahead and try to see if I can find my x-intercept. So to find my x-intercept, I'm going to set y equal to 0. I'm going to use the original problem. It doesn't matter which one you use, either the original or the new standard form you just created. So this is my original problem, and I'm plugging in 0 for y. I'm now going to follow order of operations here. Anything times 0 is 0. So now I'm just left with x minus 49. Add 49. Wow, my x-intercept is at 49, 0. That's way up there, or way down the line. All right, so let's go ahead and see if we can get this information onto our coordinate plane. Let me come over here, make my x and y axis. I'll go ahead and graph the vertex first, -1, -5. There's my vertex. My directrix is here at x equals -1 and 1/8. My focus point is at -7/8, -5. My axis of symmetry is this line right through the vertex. So let's say that my x-intercept is way down here. Let's say this is 49, 0. So your parabola would go out like this. And then over here, you could go the same number of spaces away. So I could go 6, 7, 8, 9, 10. And then I could put another point over here so it's symmetrical to get the other side. As long as you show me the work for it and say another point that's on it is fine. It would have probably been better maybe to plug in x equals 1 or 2 and get a point closer there. All right, so that is an example of a parabola, completing the square and then finding all the pieces. Let's try number 6. Let's try that one and we'll see what we're going to end up with. So as soon as I see that my x squared and my y squared terms have opposite signs, that's a little clue to me that more than likely I'm going to end up with a hyperbola. Because if you remember, the standard form has a subtraction sign in between the x squared and the y squared. Now, it may not always happen like that. Maybe we're going to end up dividing by something in the end that would end up changing it. But let's go ahead and start our process. So since it's going to be a hyperbola, the only thing that I'm going to move to the other side is the constant. So x squared, and I'm going to put my x's next to each other, and then I'll leave a space, put the y's, and then I'll put equals +8. So I'm going to complete the square for the x. I take the b term, divide it by 2, square it, and I get, I'm going to be adding in here plus -1 squared, but over here I'm just going to put +1. So I can go ahead and complete the square here and factor this. So this becomes x minus 1 squared. And then I have my y, and I can turn this, since there's no b term, it's going to be y minus 0 squared, and then it equals 9. Remember, we do not want to leave it equal to a number other than 1, so I have to divide everything by 9. So x minus 1 squared over 9 minus y minus 0 squared over 9 equals 1. Now, I just left the 0 in there. It'll help me see my center. My center is going to be at positive 1, 0. But as far as WebAssign is concerned, they would want you to change this to just a simple y squared. So there's your standard form. I've already pulled out the center. Now I'm going to go ahead and find my a squared, my b squared, my c squared, and find all the individual pieces and graph it. Remember, in the hyperbola, a squared is always first. And in this case, it doesn't matter because a squared and b squared are both the same thing. This is a squared plus b squared, so 9 plus 9. C squared equals 18. So c equals plus or minus the square root of 18. When I break that down, I get 3 radical 2. For a, it's going to be plus or minus 3. Same for b. Now for the hyperbola, we need to find the vertices. We use the a value. So we're going to take the center, and I'm going to be adding and subtracting this a value to the first letter I saw, which was x. So I'm going to be adding and subtracting 3. So 1 minus 3 is negative 2, and then 1 plus 3 is 4. So my vertices are located at negative 2, 0, and 4, 0. For my foci, I'm going to take the center, and I'm going to add and subtract 3 radical 2 to that x. So 1 minus 3 square root 2, 0, and 1 plus 3 square root 2, 0. These are the foci. For the hyperbola, you also need to find an asymptote. For the asymptote, when you see the x term first, it's going to be b over a. So k, y, x minus h. Really, the only thing we're worried about is the b over a. Because remember, this is going to be the slope that we move from the center. So however, if they ask you to list the asymptote equation, it's going to be y equals, and my k is 0, so plus or minus 3 over 3, x minus 1. So the slope, so I'm going to be, this will simplify to 1 over 1 or 1. So I'm going to rise 1, run 1 at this starting point of my center, which is 1, 0. So I start and then I move the slope. And that's how I can create my asymptotes. Let's go ahead and graph this hyperbola. Make my x and y axis. I'm going to graph the center point. It's right here. I'm now going to graph the asymptotes. I'm going to rise 1, run 1 in all directions. So up 1 over 1, down 1, here, here. Connect the points. Draw in the asymptotes. Next step is to graph the vertices. Negative 2, 0, and 4, 0. Use the asymptotes as the guide. And now also graph in the focus points. So if I do the square root of 18, which is the 3 radical 2, so this is approximately equal to 4.2. So I'm going to be graphing 1 minus 4.2. So negative 3.2 comma 0. And here it'll be 1 plus 4.2. So 5.2 comma 0. They'll be the 2 focus points. So I have a focus here at negative 3.2 and 1, 2, 3, 4, 5, 5.2. And there are your focus points. And there is your hyperbola. Yes, yes. Let's try number 7. Notice my x and my y terms have different signs. So little clue, probably again another hyperbola. I'm going to just move my constant to the other side. I'm going to write my y squared first because it's positive. Then I'm going to write the x terms, so negative 25x squared minus 100x equals 125. So I need to complete the square here and here. For the y, there is no b, so this will actually simplify into y minus 0 squared. For the blue, I can factor out a GCF of negative 25 x plus 4. And I need to leave a blank space. So in here, 25 x squared plus 4. Take the b term, divide it by 2, square it. 2 squared is 4. So I'm going to be adding in 2 squared. Over here, I'm going to be adding negative 25 times 4, which is negative 100. I now need to factor the blue. So this will turn into negative 25 times x plus 2 squared. Drop down the y minus 0 squared. And set it equal to 125 minus 100 is 25. I need to make my equation equal to 1. So what I need to do is divide everything by 25. And then this will be y minus 0 squared over 25. This one simplifies to a 1. So minus x plus 2 squared over 1. And then it equals 1. Now, again, I'm going to simplify the red to just y squared over 25. And then the blue, just put it as x plus 2 squared. Don't put the 1 in the denominator. So this is how WebAssign would look for it. So let's go ahead now and get all of the pieces for this hyperbola, and let's graph it. So a squared is always first. So a squared equals 25, b squared equals 1, c squared equals a squared plus b squared. So c squared equals 25 plus 1, which is 26. So c equals plus or minus the square root of 26. A is equal to plus or minus 5, and b is equal to plus or minus 1. I need to find the vertices. It uses the A, and you're going to add the A to the first letter you see, which was Y. So for my vertices, I'm going to take my center, which I did not write down. So my center point is located at -2, 0. So I'm going to be adding the a value to the y. So 0, and it'll be plus or minus 5. So -2, -5, -2, +5. These are the vertices. The foci will be -2, -√26, -2, +√26. Since it's a hyperbola, I also need to find the asymptote. So this one's going to be y equals k plus or minus. So since it is vertical, it's going to be a over b. So the equation here is going to be plus or minus 5/1 x plus 2. That is the equation for the asymptote. But again, remember, all we need to pay attention to is the slope here. So we'll rise 5 and run 1 from the center point of -2, 0. So let's go ahead and draw in our x and y axis. Going to graph the center. And then from here, let me go ahead and get in my asymptotes. Let me add in some markings here. So I'm going to rise 5 and I'm going to run 1. Rise 5, run 1. And get my asymptotes on the graph. So I have 1 here and 1 going this way. I'll go ahead and graph the vertices. -2, -5, -2, +5. Use the asymptotes as your guide. It doesn't cross it, skims along it. And then I also can graph the foci. The square root of 26 is about it's just above 25. So we could say it's like 5.1. So we would graph -2, -5.1 and -2, +5.1. So focus here and here. And you're done. Yes. Yes. All right, let's try number 8. Pretty good on number 7. So here again, I can see that the signs are different on my x squared and my y squared. So here again, it's looking like it's probably going to be another hyperbola. So let me move the constant. Actually, yeah, let me move the constant to the other side. I'm also going to put the y first because it's positive. So I'm going to do 25y squared minus 100y, leave a blank space, 9x squared, and then I move the constant over. In order to complete the square, I'm completing it for the y terms and for the x terms. So for the y, factor out the 25, leave a blank space. Then I need to, for the blue, x minus 0, there's no b term. For the red, take the b term, divide it by 2, and square it, and I get 4. So in here I'll put plus -2 squared, but over here you have to do 25 times 4. So what we would be adding over there is positive 100. So let me factor the red. It factors into 25 times y minus 2 squared. Then the blue. And then I'm going to add this, and I get 225. I need to set it equal to 1, so divide everything by 225. I can simplify these fractions, and then this one, 225 goes into 225 16 times, and then 9 goes in here 25 times. So this will simplify to y minus 2 squared over 16. No, wait. 9. Sorry, this goes in 9 times. Let me fix this. Goes in 9, and then this is the 25. So over 9, and then x minus 0 squared over 25, and the whole thing equals 1. Again, for WebAssign, simplify the blue to a just x squared. All right, so let me go ahead and pull my center out. My center is at 0, 2. A squared's always first. So A equals plus and minus 3. B squared is 25. C squared is equal to A squared plus B squared. 9 plus 25. C squared equals 34. So C equals plus and minus the square root of 34. I need to find the vertices, foci, and asymptote. So for the vertices, you're going to add the A value to the y of the center. So my vertices are going to be located at 0, 2 minus 3, so that's -1, and then 2 plus 3, which will be 5. The foci, 0, 2 plus or minus root 34, so 1 at 2 minus the square root of 34, and 1 at 2 plus. Since I see y squared first, my asymptotes are going to be B over A, yes.
I thought you said that A squared is always the bigger number.
That's for the ellipse.
Oh,
For the hyperbola, A squared is always first.
okay.
Okay, so for the asymptotes, here what we need to do is, we're doing A over B. So I'll fill this in as y equals 2 plus or minus 3/5 x minus 0. Main thing I need to look at is the slope. I'm going to rise 3, run 5 from this center point of 0, 2. That will create my asymptotes. From there, you'll graph the vertices and use the asymptotes as your guide. Let's go ahead and draw in the x and the y axis. Draw in my center point. I'm going to go ahead and graph the asymptotes from that center. I'm going to rise 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I'm going to rise 3 and run 5. Go in all directions, create the line through that center. There's your asymptotes. Graph the vertices, 0, -1, 0, 5. Use the asymptotes as your guide. And then also graph the foci. Foci had the square root of 34 in it. Square root of 34 is about 5.8. It's close to 36, which is 6. So I'm going to be doing 0, so I'll do 2 minus 5.8, and then 0, 2 plus 5.8. So negative 3.8, and over here, 7.8. So we can go ahead and graph 1, 2, 3, 4, 5, 6, 7, 8. So I can put a focus there and another one here. Let's try another example. Back to a parabola again. Pretty good. All right, I only have one squared variable, it's the y squared. So I'm going to move the x and the 26 to the other side. So I get y squared plus 10y, leave a blank space, negative x minus 26. To complete that blank space, I'm going to take the b term, divide it by 2, and square it. I get 25. So instead, I'm just going to show that it's plus 5 squared here, but over here, I'm going to put plus 25. I'm going to factor this trinomial. It'll factor into y plus 5 squared. Over here, I can simplify this and get negative x minus 1. I'm going to factor out a negative 1 and get x plus 1 here. And now it's in the correct format. The 4p value is that negative 1. For WebAssign, you don't need to show the negative 1. You can just leave the negative sign. My vertex is located at the order pair -1, -5. I haven't been doing this, but the axis of symmetry, or maybe I did before, is going to be y equals -5. My 4p value is set equal to -1. Divide by 4, and p equals -1/4. I'm using that p value to find the focus in the directrix. So for the focus, it's going to be the center point is, or the vertex is at -1, and I'm going to be adding the 1/4, the -1/4, to the x of the vertex. So I have a focus point at -1 and 1/4. If you want to key it in as a improper fraction, either way, but for graphing purposes, I think the mixed number is better. So this is the focus. The directrix is the opposite of p. So this one's going to be x equals -1 plus 1/4. So x equals -3/4. Let me go ahead and find another order pair. Now, when I go to find my intercept, if I try to find the x-intercept, I'm going to set y equal to 0. So 0 squared plus x plus 10 times 0 plus 26 equals 0. This is gone, this is gone. So x plus 26 equals 0. X equals negative 26. Got a x-intercept that's really far out. Now, if you're looking for a point, you can plug in whatever you want for x or y. I could plug in negative 2 for x, and then I can get my y values. It doesn't really matter. So let's go ahead and just graph this. I'm going to graph the vertex, negative 1, negative 5. I can graph my directrix, which is at x equals negative 3/4. I can graph my focus, which is at negative 1 1/4, comma, negative 5. Like right there. And then if you want to try to graph this x-intercept, we can say that it's way down here, negative 26, comma 0. So your parabola will look like this. We can use this axis of symmetry, and then we can find a point that's like 5 spaces on this side. So we can go 6, 7, 8, 9, 10, and then we could go straight below it to get the other side of the parabola. Again, you don't have to plug in 0. You can plug in whatever number you want. Another point that's on here is an order pair of negative 2, comma 4 and negative 2, comma negative 6. So negative 2, negative 4, negative 2, negative 6 would be 2 other points that are on that graph. See if I can get one more in. This one is also going to be a hyperbola. So I'm going to move the 16y squared over to leave the constant all by itself. So I get 16y squared minus 32y. Leave a blank space, write the 9x equals 128. I'm going to factor out the 16 and get y squared minus 2. For here, I can turn this into x minus 0 squared equals 128. Take the b term here, divide it by 2, and square it. Get positive 1. So in here I'm going to put plus negative 1 squared. But over here I got to remember to multiply it by 16. So I'm going to add 16. This side becomes 144. The blue will factor into y minus 1 squared. And then plus or minus the 9x minus 0 squared. Divide everything by 144. Now once I divide everything by 144, 16 goes into 144 9 times. Y minus 1 squared over 9. This will just turn into an x squared, and this turns into a 16 equals 1. So now I have it in standard form. Now I can find all the parts. So my center is at 0, 1. A squared is always first. It equals 9. B squared equals 16. A equals plus and minus 3. B equals plus and minus. B equals plus and minus 4. C squared equals A squared plus B squared. 9 plus 16 gives me 25. So C equals plus and minus 5. So to find the vertices, I'm going to take my center point, and I'm going to be adding and subtracting the A value to the Y of the vertex. So I have a vertice at 0, negative 2, and 0, 4. These are the vertices. My focus points, again, we're going to add and subtract 5. So I have a focus point here at 0, -4, 0, 6. I also need my asymptotes. Y equals k plus or minus a over b, because I see the y first. So again, my k value from the center is 1. My a value is 3, b is 4, x minus 0. All I need is the slope, because remember, you're going to rise 3 and you're going to run 4 from that center point to graph this hyperbola. Make your x and y axis. My center point is at the order pair 0, 1. I'm going to graph in the asymptotes. I'm going to rise 3 and run 4. 1, 2, 3. 1, 2, 3, 4. Add a couple lines here. Same thing over here. And then go down 3. And then over 4. Here is my asymptotes. Graph my vertices, 0, -2, and +4. Use the asymptotes as the guide. It was vertical because I saw the y first. Also graph in the 2 focus points. And you had one at 0, -4, and 0, +6. 1, 2, 3, 4, 5, 6. I've got one here. 1, 2, 3, 4, and another one here. So that concludes the notes for section 4.4.